This week I worked on three main exercises: a post-process texture to create a frozen screen effect, a fractured ice surface animation in Houdini, and a high-resolution rock generator for PBR workflows. Here is how I achieved each effect. To create the frozen screen effect, I started in Photoshop by painting icy, frosty patterns using brushes while preserving the alpha channel. These patterns were then imported into Unreal Engine to build a post-process material. For the material setup, I layered the frosty texture over the screen using the post-process material. To simulate anisotropic distortion, I used a vector blur and enhanced the effect with normal textures to add noise in view space, simulating the frozen surface. And a panel node was added to create a flowing motion for dynamic frost formation. Finally, I adjusted the color saturation to give it a cold acid tone. I applied the post-process material to the volume in my scene, resulting in a convincing frozen screen effect. The fractured ice surface was created in Houdini with an efficient method that avoids heavy simulations. Instead, I used the color attributes and transfers to achieve the fractured effect. I started with a grid and applied UV mapping to it. Using a scatter node, I generated points based on the UV layout. The rigid body material fracture node was used to break the grid into small chunks. When viewed with the exploded view node, these small chunks became visible. The ice surface was given a red color. A tube was introduced as the impacting object, generating black points within its volume to influence the red ice surface. With an attribute transfer node, I can transfer the black color to parts of the red ice, marking the affected chunks. These affected chunks were scaled and displaced downward to simulate an impact that cracks and sinks the ice. Using a split node, I divided the geometry into two groups, the ice surface and the fractured chunks. For the fractured chunks, I removed the chunks that were deeply submerged, since they would be invisible underwater. The remaining chunks were divided into two groups for independent tilting and evaporation, simulating floating ice pieces. For the ice surface, I added noise to create a subtle mountainous effect on the surface. Then the result was exported as an Alembic animation. I also adapted this method to fit the scene, creating a dynamic circular ice breaking effect tailored to the project. For the third exercise, I built a high-resolution rock generator in Houdini, designed for procedural modeling and baking. This process was intended to meet PBR standards. For high-resolution model creation, I used noise patterns and displaced points along the normal direction of a base shape, such as a sphere. The unified noise static node with the Wally cellular mode was used to generate detailed displacement patterns. Multiple layers of noise were combined for a realistic rocky surface. The bottom of the rock was flattened with placing it at y equals 0. A bounding box was calculated and a loop operation was applied to smooth the bottom edge. After completing the high-resolution model, I exposed the key parameters and created an Houdini digital asset. Using instant mesh for topology, I generated an evenly distributed low poly model. The Labs Auto UV node was used to automatically generate UVs for the low poly model. Then we need to bake the and create materials. The Maps Baker node was used to bake details like ambient occlusion and normal maps from the high-resolution model to the low-poly model. The baked textures were exported, and after adjusting the model's orientation and scale in a 3D software like Blender, the low-poly model was imported into Unreal Engine. Since Houdini's Map Baker doesn't support to bake diffuse maps directly, I used the Bake Texture node with triplanar mapping to project external textures onto the model in output. After rendering textures, I can import them into Unreal Engine, where the UVs matched perfectly with the high-resolution baked details.